Polygon, angle, sum theorems. Okay, we're dealing with polygons now. And in order to know what you're dealing with polygons, you have to know what a polygon is and how it's different or why it's specific. So a polygon, write this down. There's 3 specific things about it. It is on a plane, 2-dimensional. It has all segments, no curves, and it is closed. It's a closed plane figure consisting of segments only. And that's important because that's the only way you can count up the degrees within. If there was a curve, then that would throw you off. The sides are these straight segments. The vertex is that corner. And there are 5 vertices in this case and 5 sides. The number of vertices should always match the number of sides. The side of a polygon is the edge, and the vertex of a polygon is the corner, okay, where the 2 sides meet. A diagonal. A diagonal is when you have a segment drawn from corners that are not consecutive. So this corner is next to this corner, that's a side. But if you draw from a corner to something across from it that's not next to that corner, you get a diagonal from here to here. You can't go to the one beside, you go this way and this way. Those are the diagonals. Okay, so it's a segment connecting 2 non-consecutive vertices. In other words, it's all the segments you could draw besides the sides themselves. So this segment is a diagonal. This segment right here is a diagonal from here to here and here to here. Anything that doesn't actually make an edge is a diagonal. Alright, so go to, or look at the one below. Oh, I'm sorry. Actually, turn the page. Turn to this chart right here. And let's see how many of these you know and how many of these we need to look up. All we're going to do is go down the left-hand side and figure out what the name of the shape is. So, if you have a polygon that is 3 sides, you know that name. What would that be? Triangle. If you have a polygon with 4 sides, do you know that name? Quadrilateral. Let's see how far you guys can go before I have to help you. Do you know what 5 sides would be? Pentagon, it starts with a P. Pentagon. Write that down. I'm a little bit stressed out about my computer giving me crashes. I'll slow down a little bit. Like, beat the computer. Quadrilateral. You guys know that word. Know some of the future ones? Alright, everyone got quadrilateral? Alright. Pentagon, a little shorter. Pentagon. Okay. Number 6, someone said it already, right? Hexagon, good. Megagon? Okay, some books say septa, some say hepta. We're going to H. Heptagon. Some call it the 6-9 sexagon and septagon. Just depending on which language you derive it from. Heptagon is 7 sides. Some people say septagon. Say both. Does anyone know 8 sides? Octagon. Everyone got those? Does anyone know the name for 9 sides? Right. Nonagon. Okay. N-O-N.
Just make
Like a southerner saying ninagon. They say nonagon. $11 doesn't have a special name, and we'll get to that in a second. What you do when there's no special name. That is what you call it. 11 gon, that's right. Number 10 has a special name still? Decagon, that's right. 10s are like decas, like deciliters and deciliter and decas. And number 12 actually does have a special name still. Dodecagon. Dodecagon. So you said, what about the 11th one? when there's no special name for it, you just use the number. You say 11 gon. Or if it's 15 sides, you say 15 gon. Or if it's 100 sides, you say 100 gon. Okay? Or to the end. All right, now you have to keep that in mind as you do the next part now. Look back to your old notes. We're going to build on this chart as it becomes appropriate to what we're doing. But go back here. We have to first of all decide if this is a polygon. Is it closed with no open gaps in it? Is it all segments? And does it fit on a plane? Yes, this is a polygon.
Yes.
So the next thing to do is, if it is a polygon, name it by the number of sides. What's the count? 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So we call it a back to the front page. Nonagon. Okay, so all those names up to 12, you should be getting to know pretty well. Number 2, is that a polygon? No, because the sides are not all straight. It has curves. Polygon has to be all straight segments or else it won't work. Is number 3 a polygon? No. It has a polygon in it, but overall it's not a polygon because it has a gap.
No.
And it also crisscrosses or overlaps. It has a gap. You can't have any open spaces and call it a polygon. A couple more things you need to know. A regular polygon is equilateral What does that mean? Equal what? Equal sides. And it's also equiangular. All equal angles. Alright, that says equiangular. Okay, so it's regular if all the sides are the same and all of the angles are the same. Okay, the rules that we're going to be applying are going to either be specific for regulars or else it'll apply to everything. You have to know that about the particular rule that we're looking at. Concave. Concave means that parts of the sides cave in. Okay, the sides can cave in. Like these two sides, like there's a part that's caving inward. That's what concave means. There's a scientific definition for it, but for our polygons, that's what that means. You guys probably heard that word in science with concave lenses and convex lenses and microscopes and telescopes and all that. Okay, convex is where no sides are caving in. All the sides are going outward. That's what concave looks like. Can't find any piece that's caving inward. So we have to decide, are they polygons, are they regular or irregular? Are they concave or convex? So first of all, does every single segment here match every other segment? 4 do, but the 5th one doesn't, right? These 4 match, but this one doesn't. It's actually longer than all the rest. So no, it's not regular. These angles don't match this angle right here, this really big angle. So no, it's irregular. Is it concave or convex? Concave is that piece caving in there. So it's irregular and it's concave. Irregular and it's concave. If someone's phone accidentally goes off, it doesn't bother me as much as if someone's purposely on their phone texting while I'm trying to show you. So you know. Number 6, what's this one? Regular or irregular? Regular. Everything's marked equal. And is it concave or convex? Convex. Good. There's nothing caving in. It's regular, everything's equal, and it's convex, nothing's caving in, everything's pointing outwards. And number 7, is it regular or irregular? Irregular. These 2 don't match the rest of them. That right angle doesn't match the rest of them. Is it concave or convex? Convex. There's nothing facing inwards. So you need to know these words just as they apply to the rules that we're going to be having at different times. Regular applies to some rules. Irregular will apply to others. Alright, that's the basics of the definitions. The last thing you need to know is this rule. And we're going to get into it a little bit, and then we'll get into it more in-depth tomorrow. You guys know that tomorrow's late start day, right? Alright, the interior angle sum theorem. Sometimes you'll hear the polygon angle sum theorem. Sometimes you'll just hear the angle sum theorem. Okay? Our book calls it the polygon angle sum theorem. So, get this formula, memorize it, know it. You're going to be using it over and over again. It's going to look a little strange at first, but once you get used to it, it'll be really familiar. The sum of the interior angle measures of a polygon, any polygon, with n sides is n minus 2 times 180. 180 degrees, the sum of a triangle, and then you multiply it by 2 less than the number of sides. N stands for the number of sides. That's right here with n sides. So for example, this one right here, how many sides are there? 5. N equals 5. There's 5 sides. So I'm going to figure out the sum of all the angles. If I added up this angle, this angle, this angle, this angle, and this angle, what would I get? Yep, let's do it. It's 5. What? Minus 2. Got to do inside the parentheses first. That's 3. And then multiply it by 180. So what do we actually get? You don't have your calculators? I'm doing this in my head. Someone can check it with your calculator though. See, someone have their calculator check that because I'm just doing that from memory. Actually, I can look at the next screen where I did it. Yeah. Okay? So it's all you have to do is take the number of sides, subtract 2, multiply by 180, and that'll give you the total. And this is important for when you're trying to find a missing side, especially in the word problems. Next rule, exterior angle sum theorem. What's the difference between this one and the top one? Okay, the drawing, but what about in the words? Good. One's inside, one's outside. What's exterior? The interior sum uses this formula. The exterior sum uses this one. The sum of the exterior angles, one at a vertex, is 360 degrees. There's no n there. It doesn't matter how many sides there are. They will always come out to be 360 degrees. Always. No matter what. Okay? Always, 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 always.